Hello, this is Lee Jun-hyuk with A New Beginning. From this session, we will be dealing with a product called PC2. It is a product that is quite frequently used in image recognition projects. As you can see here, it is available for purchase on the DeviceMart website. You can go directly to the sales page through the link below or the YouTube card. I will explain in detail later, but to briefly look at it, it looks like this. In fact, it is quite small, measuring less than about 5 cm. Looking at the possible tasks, you can track learned objects, use it for line tracking in robot navigation, or recognize hundreds of objects simultaneously. It can be used in various vision recognition projects. I will explain in detail while looking at the slides. First, if we look at the specifications, it is equipped with an NXP LPC4330 204mm dual core as the main processor. And it also has a separate image processor, the Aptina MT9M114, which can process images with a resolution of 1290x976. The RAM is 264 KB, the flash memory is 2 MB, and the size is 3.8 x 4.2 x 1.5 cm, making it quite small at less than 5 cm, and it weighs 10 g. It also has built-in lighting, which is brighter than the typical iPhone light, thanks to its own Eisenroman lighting. Looking at the exterior, there are LED lights on the left and right, and built-in lighting, and it recognizes objects through the camera lens in the middle. There is a button on top that controls the Pixy, and there is an RGB LED at the bottom that indicates the objects being learned and recognized. On the back, there is a micro 5-pin USB on the left for communication with the PC, and an I/O port on the right for connecting to desired microcontrollers like Arduino or Raspberry Pi, allowing communication via UART, I2C, or SPI. Additionally, even without microcontrollers like Arduino or Raspberry Pi, the PC2 can be controlled independently. And there is a servo motor port at the bottom of the I/O port for controlling servo motors. The PC2 is an updated model from the PC1, and some of the features from the PC1 include its small size, ease of use, and significantly lower cost compared to other vision recognition related economic products. Even without background knowledge in vision recognition, you can easily carry out vision recognition projects using Pixy2. With the transition to PC2, the line tracking function has been enhanced. And with 60 frames per second, you can receive 60 pieces of data every second, allowing for rapid object recognition. As I will explain later, the algorithm for distinguishing objects based on color has been significantly enhanced, and it provides libraries for various platforms such as Arduino, Raspberry Pi, Lego Mindstorms, and EV3, making it easy for you to write code for each platform. And the built-in lighting, as I mentioned earlier, has been added this time. While working with PC tools, I would like to briefly touch on image recognition. Image recognition is used in a wide variety of fields. For example, you can use image recognition to identify agricultural materials or specific agricultural materials you want, or to recognize desired electronic components in a factory, or to identify toys you want in a DIY project. Whenever you undertake a desired project, you can use this image recognition by optimizing the algorithm to recognize the desired objects. However, the drawback of image recognition is that the size of the image changes depending on the resolution, and a large number of images will be needed, and processing all those images will require a lot of resources from the processor. Additionally, we generally do not only perform image processing, but also control LEDs or motors. When performing such tasks along with image processing, it can be quite challenging. In this regard, the PC2 is quite useful. As I mentioned earlier, it processes images separately with the main processor and the image processor. And when it comes to the processed information, it is neatly organized and only the necessary information is conveyed to devices like Arduino or Raspberry Pi. For example, It can specify that a toy is located at coordinates x54, y103. It is located at y103. The information is organized neatly, and it delivers such information at 60 frames per second, providing 60 pieces of data per second, and you can receive this information through your desired interface, whether it be UART, SPI, or I2C. By organizing information neatly like this, even microcontrollers, especially Arduino, which only has 8-bit performance, can receive this information and control LEDs or motors. Additionally, with PC2, you can control multiple units simultaneously. For example, you can use 4 units to recognize all objects in the north, south, east, and west. Moreover, you can use PC2 without microcontrollers like Arduino or Raspberry Pi. In this case, you can connect the servo motor directly to the PC2, allowing the PC2 to control the servo motor on its own and track the learned objects. The PC2 has an algorithm called CCC, Color Connected Components, that detects objects based on color. The speed is very fast and efficient, but the drawback is that it can be significantly affected by the surrounding environment, causing the accuracy to fluctuate considerably, because the saturation of colors can change depending on the surrounding lighting environment. So, despite such drawbacks, it is very fast and efficient. In this way, it can distinguish objects based on a total of 7 basic color categories and simultaneously recognize hundreds of objects. Additionally, you can train the PC to recognize the desired object by placing the object in front of the camera lens and clicking a button, allowing the PC to learn. When learning, it displays the learning information results using an RGB LED. Then, the learning results are stored in flash memory, and based on the 7 color categories I explained earlier, it learns and later recognizes objects based on this. And it is said to recognize hundreds of objects in total, assigning an index from 0 to 255 to each object. The index might change with each frame. However, in the case of a PC, even if the frame is updated, if a specific object is determined to be almost identical to the object in the next frame, that object is assigned the same index as in the previous frame. So, we have set it up with an index to easily track the objects you want. And there is something called a color code in the PC, which allows you to combine colors like pink and green to indicate, for example, the location of a charger. By using these color codes, you can convey specific commands or information based on color. This method allows you to accurately communicate details such as exact location and size, and it can be very useful for robot navigation. However, the drawback is that, as we saw earlier, you need to attach specific color-related stickers to the desired object to use this. Additionally, some objects already have a unique color. If an object already has a distinctive pink color that sets it apart from others, there would be no need to use a color code. In the case of the PC2, the line tracking feature is enhanced, and this line tracking technology is widely used in the field of robotics. It navigates the robot by telling lines from the background, but setting the direction at intersections is difficult. However, in the case of the PC2, it not only recognizes lines, but also analyzes vectors, determining exactly where they start and end and how the direction of movement proceeds. And as you can see in the video, it is possible to give commands or provide additional information through barcodes or similar means. And similarly, it can use 60 frames per second, which means 60 pieces of data per second. In this way, it is possible to recognize intersections, and it can be set to recognize not only black lines on a white background, but also white lines on a black background. Additionally, you can configure it to recognize lines of a specific width, whether they are thick or thin, according to your preference. This is referred to as a vector, and it can also inform you where each line starts and ends in each frame. And just as it was mentioned that the index is shown consistently based on the continuity, between each frame. Here too, the robot is indeed guided to move along the same line, considering the continuity between each frame. As follows, it can now recognize Y intersections, T intersections, 4-lane roads, and star intersections. You can use barcodes, and by setting the barcode, you can instruct it to turn left, turn right, or convey some information. The screens we've seen so far are from a program called PCMon, which is used in conjunction with the PC2. Using this PCMon program, you can extract information about desired colors from video or image files on your computer. We've looked at the PC2 this time, and from the next session, we will start setting up the PC2 in earnest and see how to handle the PC2 in detail. I'll see you next time.